In this presentation, we examine flowcharts. So flowchart is a diagram with symbols that shows the steps required to solve a problem. It can be used to represent an algorithm, and it helps you plan your code before you start writing it. So with flow diagrams, we have a whole range of symbols, but the ones we're going to look at, or the main ones that we're going to look at, are these ones presented here. So we'll go through each of these in turn now. So start and stop, these are probably the simplest symbols that we look at. So these are a rectangular box with curved corners to it. So this just tells us when our flowchart starts and when it stops. So a decision is the same as an if-else statement in code that we write. So the decision takes the form of a diamond shape, and if the decision has a yes outcome, then we do something, but if it has a no outcome, then do something else. So a decision is normally posed as a question. A process is represented as a rectangle, and a process is a task that the algorithm performs. So often we use a verb to describe what process is being performed. And input-output is the shape of a parallelogram. It represents the data that we're entering into the program, into the algorithm, and the output, so what's printed out at the end. What we're going to do now is we're going to create a flowchart. So we're going to apply some of those shapes to create a flowchart. And the example we're going to create is a flowchart for a thermostat. So the idea here is that if the temperature gets above 21 degrees Celsius, turn off the heating. If the temperature gets below 20 degrees Celsius, then we turn on the heating. So to start with, we have our starting block there. Next thing we need to do is we need to check the temperature to make sure, or to identify whether it's below 21 degrees Celsius, above 21 degrees Celsius, or below 20 degrees Celsius, or above 20 degrees Celsius. We need to check temperature to see what we need to do with that. So the first thing we need to do is to identify whether the temperature is too cold. If it's too cold, then we need to do something. If it's not too cold, then we need to do something else. So the thing that we need to do if it is too cold is we need to turn on the heating. Okay, once we turn the heating on, we need to go back and to check the temperature. So we need to constantly go back in this flowchart to constantly check the temperature. So now we've identified what we need to do when the temperature is too cold. Now we need to figure out what happens when the temperature is too hot. So if it's above 21 degrees Celsius. So if that's the case, then we need to have another decision here. So if it's too hot, we need to do something. If it's not too hot, then we need to do something else. So if it's too hot, then we need to turn off the heating, as you can see, and we turn off the heating and then we go back to check the temperature. And if it's not too hot, then we don't do anything except go straight back to check the temperature. So whatever outcome we have, we always have to go back to check the temperature to make sure that it's constantly being regulated, temperature is being regulated within 20 degrees and 21 degrees Celsius. So this program looks to see that the temperature is maintained between that range of 20 degrees Celsius and 21 degrees Celsius.